Chapter 4, looking at transformations. I'm going to start off with translations. Our essential question: how can you translate a figure in a coordinate plane? One of the things we use to do that is a vector. So a vector is a quantity that has both direction and magnitude or size and is represented by the coordinate on the coordinate plane by an arrow drawn from one point to another. So here we have an example of a vector. Right, we have our initial point. We have where we're going to. Right, so here we have FG, which is read as vector FG. So we have the horizontal component and the vertical component. When we look at this, this is a little hard to see here. This is FG, and you just have an arrow above it. So unlike the ray, you don't have an arrow per se. You have a line with one line coming up. So that signifies vector rather than ray. So a ray goes on forever. The vector actually does stop here. The arrow is showing the direction. We also have a component form of this. So the component form of FG, you have the arrow brackets, 5, 3. So this is saying I go 5 units to the right and 3 units up. If I was moving left, it would be negative. If I was moving down, it would be negative. Okay. Similar to array, when we name it, right, we always go left to right, no matter what direction it is. Looking at it would show us the direction. So when we look at example 1 here, they goes 4 things. Ask us to name the vector and write its component form. So here we have B going to C. So my vector would be BC. And then my component form, I come over 1, 2, 3, 4, 5, 6, 7, 8, 9. And I come down 2. So that would be my component form and the name of my vector. For B, we have ST as the name of my vector. All right, come over 1, 2, 3, 4, 5, 6, 7, 8. Okay, and going to the left, so that's -8. We don't go up or down at all. So -8, 0. C is a little confusing how it's drawn. The A actually goes up here where our arrow is. Our B is here. So our vector is BA. And I come over 1, 2, 3 and go up 2. So I have -3, 2 as my component form. And then D, we have JP as our vector. And I'm coming up 1, 2, 3, 4. And I don't move left or right at all. So I have 0, 4 as my component form. We can use these to do transformations, which is why we use them. We'll start with them. Okay, then we're going to look at some definitions of some of our stuff more related to transformations. Oh, it's blurry. There we go. Transformation is a function that moves a figure, right? A function that moves or changes a figure. Our pre-image, a pre-image is the original figure in the transformation of a figure. The image is the new figure produced from a transformation. Okay, and the image part normally sometimes confuses people because they think of image as the original. Pre-image is your original, image is the new thing. So here, it's a little hard to see what they're doing here. They have a line here, that's my pre-image. They move that along this vector here. So this is my image. Okay. And it's hard to see these. This is P, this is P prime, okay, which I'll show a bit better on the example 2 here, but that's how we label our pre-image and our image. And then a translation moves every point the same distance in the same direction. So example 2 says the vertices of the triangle ABC are -5, -3, 2, 4, and 1, 2. Okay, translate the triangle using the vector 5, -1. Graph the triangle ABC and its image. And so I already have the two graphs on here. The black is your pre-image. That's your original. Okay, so I have A, B, and C that are at the given points. Okay, then I'm moving 5, -1. There's a couple ways we can do this. If I'm doing it on the graph, I can just count. So like from A, I count over 5 and down 1. From C, I count over 5 and down 1. From B, I count over 5 and down 1. Those are my new points, my images. Okay, and if you notice, I have A and A prime, B and B prime, C and C prime. Okay, so the prime, the dash there, shows that it's the next iteration. If we're doing 2 moves, we would have 2 dashes, which would be double prime. Okay, you can also add and subtract. So I can do -5 plus 5 to get 0, and -3 plus -1 to get -4. If I look at my A, that's where that point is. So that is another way to do it. And that's part of what we'll use as we look down below here. Okay. So we have a translation can be expressed using a rule in addition to the vector and in addition to the vector component. So AB here is my component form. The rule would be x plus A, y plus B. So here 6, -1 as my component form would be x plus 6, y minus 1. Okay, so then if I plug my points in there, I could find my value. Example 2 says use a translation xy to x minus 2, y plus 5. Okay, so this is our rule here. So it says what is the image of A to 6? So it'd be A prime. And then I'd subtract 2, which gets me 0. And I'd add 5, which gets me 11. Then it asks, what is the pre-image of A prime -3 minus 10? So here we're going backwards. We're going front. We're at the image. We're looking for the pre-image. So this is going to be A. And instead of subtracting 2, I'd add 2 to get -1. Instead of adding 5, I subtract 5 to get -15. Because I'm going the opposite direction of the rule. Because I'm going from the pre-image to the image. C would be looking at the same thing. What is the pre-image of A prime to 5? So A then, I'm going backwards. I'd add the 2, so I've got 4. And I'd subtract the 5 and get to -10. Then example 4. Okay. Says graph the quadrilateral ABCD, okay, which again is here in black. All right, find the image of each vertex after the translation xy to x plus 3, y minus 1. Then graph the image using prime notation. Okay, so to get from A to A prime, I add 3 to my x, subtract 1. Again, if you have the graph, you can do that by counting. So I can count over 1, 2, 3, and then down 1. Or I can do the math. -1 plus 3 is 2. 2 minus 1 is 1. So that's where my point is. So I do that with all my points. And this is my graph here. Make sure to watch what they're asking for you to graph. This says graph quadrilateral ABCD and then graph the image using prime notation. So I need both pictures there. Okay, sometimes they ask for one or the other. In this case, I need them both there. Rigid motion or isometry is a transformation that preserves length and angle measure. Okay, so the images are going to be congruent. So isometry is another word for congruence transformation. So if I look at what we've done here, these two pictures are both the exact same size. That's because a translation is a rigid motion or an isometric transformation. Okay, so we're always going to see that with what we're working with on translations. There are some transformations that are not isometric. We'll talk about those later. Example 5 says write a translation rule and verify congruence. Write a rule for the transformation from triangle ABC to triangle ABC. So basically, I'm looking at how do I get from one of these points to the other. Make sure you're starting at the right one. Here, this is A prime, C prime, and B prime. So this here is my pre-image. That's my original. So when I'm moving from A to B, from A to A prime, I come back 1, 2, 3, 4. Okay. So I have -4, and then I go up 1. Okay, so that's my component form. It actually asked me to write it as a rule. So the rule would be x minus 4, y plus 1. And verifying congruence, I can look at the size, or I can make sure these all move the same way. If I move C, I come over 4 and up 1. When I'm moving B, I come over 4 and up 1. Okay, so that's a way to check it. Or you could check and make sure all the sides are the same, which is a little bit harder on this one. Okay. For the next two, I'm not going to check that. I know these are congruent. All right, so the rules will work. So B, P, S, R, Q is my original. P prime, S prime, R prime, and Q prime is my image. So I want to go from R to R prime. I come over 1, 2, 3, 4. And I go up 1, 2, 3. So I have X plus 4, Y plus 3. Actually, those are parentheses when I'm doing the rule. All right, we're doing the rule. Oh no, actually we use this. Oh, what do they do up here? All right, they use parentheses. I think either is okay. I normally use the arrow brackets, but our example 3 used the parentheses, so that's what we'll do. And then here, again, our solid one, PQRS, is our original or our pre-image. P prime, Q prime, R prime, S prime is the image or a new one. So if we're moving from S to S, we come over 1, 2. No, actually we come over 1, then come down 1, 2, 3. Right, so I have X plus 1, Y minus 3 as my rule. Oop, which I can't see there. There we go. And example 6, use point -3, 6. Find the component form of the vector that describes the translation from our original point to P prime, -4, 8. So component form, we're doing the arrow brackets and just putting in the numbers. To go from -3 to -4, I subtract 1. To go from 6 to 8, I add 2. So that would be my component form. B, find the component form of the vector that describes the translation to 0, 5. So I'm starting at the same spot. -3 to 0, I'm adding 3. 6 to 5, I'm subtracting 1. So that would be my component form. Composition of transformations is when two or more transformations are combined to form a single transformation. This is not super useful with translations, though we're illustrating it with translations. But as we go and add more transformations, this becomes more useful. So we have graph segment RS with endpoints -8, 5, and -6, 8. And its image after the composition. So we're going to move here. So I'm looking at R prime, S prime. So I add 5 and subtract 2 from both points. So -8 plus 5 is -3. 5 minus 2 is +3. -6 plus 5 is -1. 8 minus 2 is 6. So that's my new R prime and S prime. And then I'm going to translate this new point, the image R prime, S prime, using this translation. So I'm going to have R double prime, S double prime. So -3 minus 4 gives me -7. 3 minus 2 gives me 1. And then -1 minus 4 gives me -5. 6 minus 2 gives me 4. Okay, so that is my final transformation. Okay, and then I've drawn this out with colors here, so I think it'll be a little bit easier to see. Right, when we graph it, right? So our original is RS. Okay, R prime S prime, right, which we said is at -3, 3, -1, 6, is this line here, and then the final translation is this one here, right, which is blue. This technically says graph segment RS and its image after the composition. So technically, by the rules, I don't need to graph the red one. If it's a lot of times people will find it easier to graph all three, but technically what I need here is RS and R double prime, S double prime to get full credit for this problem. And that is our translations.